Hello everybody! In this video I'm going to show you how you can build such a smart little advisor device which you can place behind your washing machine or dryer and which will tell you when it's the optimal time to turn on your washer or dryer based upon the excess solar energy coming from your roof. Now let's dive in! Let me first show you how it works. I built an electronic advisor for when to turn on the washing machine and the dryer. This little device tells my wife and me now when it's the optimal time to wash or dry our clothes based upon the excess solar energy coming from our roof. It works like a traffic light. It's only green when there is a lot of sun on the roof and not a lot of electrical load in the house. Isn't that great? Now I'm going to tell you which parts and tools you need in order to build this for yourself. You need an ESP32 dev board. You need a round GC9A01 TFT display. You need some jumper wires. You also need a USB cable to power your ESP dev board, and also you need some M2 screws. You need a CAD app, a slicer app, and a 3D printer with some filament in your favorite color. You need a Home Assistant installation, you need the ESP Home add-on installed, and also you need an integration of your inverter that tells you how much energy is currently being produced on your roof. Now let's dive deeper into the implementation part. The first step is to flash the ESP dev board with ESP Home. This will be described in numerous tutorials out there, so I don't want to go into detail here. The second step is to set up the wiring from the GC9A01 TFT display to the ESP dev board. An example wiring can be found in this picture and will be also available via my Medium blog later on. The third step is to set up the Home Assistant integration forecast.solar. This will help you to forecast your solar energy yield and will be used later on to predict how much solar energy will be available in the upcoming hours. The fourth step is to develop the ESP Home YAML configuration file and flash the configuration to the ESP Home device. An example file can soon be found via my Medium blog. Now we've set up the basic electronics components and the software. We can now try out whether the display works as expected. The next step is to design a housing for the device in a CAD app. I have done that already for you and I will provide a link to the STL file in the video description. Nevertheless, it might be necessary that you design your own housing if you want it to look differently, or for example you want to use a different kind of ESP dev board that you want to attach to the housing. The next step is to slice your housing with a slicer app and send it to your 3D printer for printing. Or you can just use the STL file and send it to an online 3D printing service so that they will print it and send it to your home. Now you have to glue the display with hot glue into the top part of the housing so that it will look like this. After that, you attach the ESP dev board to the bottom part of the housing by using some small M2 screws. The very last step is to attach the bottom part of the housing to your wall, for example by using some screws, and you close the device by attaching the top part to the bottom part. And that's it! I hope you enjoyed this tutorial. If you like my content and you want to see more, please subscribe to my channel. You can find me on Instagram, YouTube, Facebook and Medium.com. On Medium.com you will find my blog with all the detailed descriptions.